Welcome back, class. Today we will discuss about the nitrogen family, and this is the last topic of last unit of inorganic chemistry, nitrogen family. So this is the lecture number 1, and in this particular lecture we will discuss the structure of oxides of nitrogen. Okay, and if possible then we will discuss the acidic strength, the relative acidic strength of these oxy acids. So the nitrogen family, the members of nitrogen families are nitrogen, then phosphorus, arsenic, As, antimony, and bismuth. The electronic configuration: 1s2, 2s2, and 2p3. So the outermost valence shell contain 5 electron, in which 3 is unpaired electron and 2 is the paired electron. So the structure is look like this: 1, 2, and 3. The Lewis dot structure 4 and 5. So these 3 unpaired electron will form 3 bonds. So this is the how the bond formation occurs. But here in this particular lecture we are going to discuss about the oxides of nitrogen. So our concern is on oxides of nitrogen. So the oxides of nitrogen oxidation number, then the formula, and then the name. So the ratio is oxide, that means nitrogen and oxygen. So we will discuss the first, that is the very first is the N2O. One nitrogen oxide. The oxygen state here is +1. Then N2O2, it is also NO. So here the oxygen state is +2. Then N2O3. So oxygen state will be +3 here. Then N2O4 or NO2. Oxygen state is +4. And then N2O5. So oxygen is +5. So this is the 5 oxides of nitrogen. The names of these oxides are: the first is the nitrous oxide. Nitrous oxide, this is also known as laughing gas. You must remember, this is the laughing gas. Okay, then this is the nitric acid. This is called nitrogen trioxide. This will be nitrogen tetroxide. And this will be the nitrogen pentoxide. So here the +2 oxidation state with NO2 NO, and the +4 this with the NO2. So these two are actually, if we can say that, if NO and N2O2 is the dimer of this NO2 and N2O4 is the dimer of this NO2. Okay, but the oxidation number will be same whether you are talking about NO or you are talking about N2O2. The oxidation number will be same. Similarly, in case of NO2 and N2O4. Okay, now it's time to discuss the structure. This is actually very important structure. So I will give a detail about the one or two structure, and then you can understand that what is the chemistry behind this. So let's start with the very first, and that is N2O. So as you know that how we will draw the structure, the Lewis dot structure, that is the total valence electron. So total valence electron in this case is what, 5 into 2 plus 6, that means 16 electron is total. Okay, then uh, the structure. So we have a 2 nitrogen and 1 oxygen. So 1 nitrogen is in center, 1 oxygen is bonded with an oxygen, this is with another oxygen. Then we can put double bond or triple bond, or these are the resonating structure. Okay, so it can be more than that, and then we will find which one is the more stable. Resonating structures are equal in terms of the bond pair electron and lone pair electron, or in terms of the electrons. Okay, so nitrogen is with oxygen. Here we can sorry, here we require 2 nitrogen, no? Sorry. This is the nitrogen. Okay, so first we complete the octet. So octet of nitrogen, here if we want to complete, so we can put 3 bond, huh? So in this 3 bond and with this lone pair, the our nitrogen octet, this nitrogen octet is complete. Similarly, this nitrogen octet is also completed because 3 and 4, this oxygen required 3 lone pair of electron in order to complete the octet. So this is how the octet will complete. Then we go for the second. Okay, so how this will happen, this lone pair will shift here and this will go here. So now the nitrogen, then nitrogen, and now the oxygen with the double bond. In this case we have 2 lone pair, and here we have a double bond, and in this case we have 2 lone pair. So all the octet is again completed. Okay, then can we go for the third structure? Yes, we can go for that also, because this will shift here and this will go here. So the third structure of this will looks like nitrogen, then the triple bond nitrogen, sorry, single bond nitrogen. Here we have a lone pair. Okay, and then the triple bonded oxygen with one lone pair. So these are the probable structure, the organic structure of N2O. If you count the bond pair and lone pair in every case, you will get the same result. Bond pair, so 3 and 4, that means total 8 electron. Lone pair we have 1, 2, 3, 4, that means total 8 electrons. So the total electron will be 16. Similarly, in this case, bond pair 8, 1, 2, 3, 4, 4 bond pair, that means 8 electron. Lone pair 4 and 4, 8, so this will be 18, 16 electron. Here in this case also bond pair 3 and 4, 8 electron, and a lone pair is again 6 and 8. So what does it mean? It means in every resonating structure, the total number of electrons will remain same. Only the arrangement will change. The electronic arrangement will change. Now, out of these three structure, I am discussing one structure or two structure in only detail. Now, then you have to find the other structure. So, what is the which one is the most stable? All are the resonating structure, but one of them is most stable. Okay, so for that we need to calculate the formal charge. So there is a very simple method. It's a very simple method to find out the formal charge. We'll start with this. Here you can see that oxygen outermost valence electron is 6, 1 electron, 2 electron, 3 electron, 4 electron and 5 electrons. So here 1 electron we required. Okay, 1 2 3 4 and 5, 1 required, so here it will be plus 1. Okay, additional plus 1. Now we'll go for this nitrogen. 1 2 3 4. Okay, 1 2 3 and 4. So here again we required 1 because nitrogen contains plus 5. 5 unpaired electron, sorry, 5 outermost valence electron, so here plus 1. Then this nitrogen 1 2 3 4 5 6 7. Here what we have, 2 electron is in excess. Okay, so these 2 electron can be removed, that means the minus 2. So this will be balance, minus 2 plus 1 plus 2. So this is overall a neutral molecule. So this is how the uh, formal charge is calculated. So what about this one? 1 2 3 4 5 6 is complete, so formal charge will be 0 here. What about this one? 1 2 3 4, 1 is required, so what is here? It will be plus 1 here. 1 2 3 4 5 6, and nitrogen contain 5 valence electron, here is 6, so we have to move 1, so this will be minus 1. So minus 1 plus 1 0, and it is 0, so it is electrically neutral. Then 1 2 3 4 5 6 7, 1 electron is in excess, so we have to remove that 1 electron. Okay, so here minus 1. 1 2 3 4, we required one more, so this will be plus 1. 1 2 3 4 5, it is equal, so it will be 0. So this is how very simple and very easy way you can calculate the formal charge. Okay, now how we will determine that which one is the most stable resonating structure. So one or two things one should keep in mind, that the most electronegative atom must carry the negative charge. Okay, so here we'll consider only this. The most electronegative atom must carry the negative charge. Okay, so we will check in the first, this is the first case, this is the second case, and this is the third case. So here oxygen is electronegative, so oxygen carry a negative charge. Here oxygen is electronegative, but it carry a zero charge, there is no charge in this case. In this case oxygen is electronegative, but here oxygen is carrying plus charge. So if we consider this point only, out of these three, only in this case oxygen is carrying negative charge, so this will be the most stable. Although other structures are also correct, but if you consider the stability in terms of the electronegativity, atom electronegativity, this will be the most uh, stable one. Okay, so one, then here compared to these and these two, oxygen is positive and oxygen is neutral, so neutral is better than positive, so 2 and then 3. So this is what the order of stability. Okay, but these are the resonance, they electronically they are equal. Okay, so this is how you have to draw a structure of N2. Okay, now We'll go for the second, and that is NO. So NO is nitric acid. So here we'll count the total valence electron. So total valence electron in this case is 5 for nitrogen and 6 for oxygen. So this will be 11 electron. Now here is a problem, because in order to write the Lewis dot structure or resonating structure, we should require the whole number, that means the even number. So either it can be 10 or it can be 12. It is not possible for N only. Okay, so in this case NO is available in two form. NO is available in two ionic form, and these are the cation and anion. Cation is NO plus and this is NO minus. So in case of NO plus, what is the total valence electron? 5 plus 6 and minus 1. So this will give you 10. 5 plus 6 and plus 1, this will give you 12. So one that positive is nitrosinium ion. Okay, so we will draw any one of the structure, and on the basis of that structure you can draw the other structure. So let's talk about the nitrosonium ion, which is actually very important. Nitrosonium ion. Okay, so nitrosonium ion. So in this case we'll first write the N and O, nitrogen with one oxygen. We can go for the triple bond also. Still the octet is not complete, so we will put one lone pair here and one lone pair here. So this is how the valence will complete. Okay, then we will go for the resonating structure. So one of the electron will shift here. So this will give nitrogen double. No, in this case this bond bonding electron will shift to the oxygen atom, and in the third case the next one will shift to the oxygen atom. But one problem with this, because here in this case as you can see that the octet at nitrogen is incomplete, only 1 2 and 3, that means the 6 electron is there, whereas the octet at oxygen is complete. Here also the octet at oxygen is complete, but nitrogen is incomplete. So this is actually not the correct one, no? Because if we calculate the bond pair and the lone pair, in this case so bond pair is 6 electron and lone pair is 4, so total is 10. Okay, no problem with that. Similarly in this case the bond pair 4 electron and lone pair is 6, so total is 10. In this case also bond pair is 2 electron and lone pair is 8. So bond pair lone pair combination is correct, total electron. but as per the octet rule it is not the correct one. Okay, so this one is the, although if you go for the formal charge, the formal charge in this condition 1 2 3 4 5, so here we need one more, so plus 1. Here the formal charge will be 0. 1 2 3 4 5 6, so no formal charge here. 1 2 3 4, so we required one more, so here is plus 1. In this case 1 2 3 4 5 6 7, 1 is in excess, so minus 1. 1 2 3, 2 required, so plus 2. So all case will give you plus 1 charge, no, plus 1 here, plus 1 here, and plus 1 is here also, plus 2 minus 1 equals to plus 1. So in this is how the NO plus structure we can draw, okay, with the 10 electron system. Similarly you can go for the NO minus. Now we will go for the next, and that is the N2O3, the third one. So the third is N2O3. Now I will only draw the final structure, okay, because the video is getting longer. So nitrogen tetroxide, the total valence electron, sorry, trioxide it is 5 into 2 plus 6 into 3, so this will be 10 and 18, that is a 28. Total valence electron is 28. And as it here we have 2 nitrogen, so we'll go for the structure nitrogen and nitrogen, 2 nitrogen, and one can put double bond here, a single bond and double bond. Now let's check the octet at the center atom. So this nitrogen 1 2 3 4, octet is complete. This nitrogen 1 2 3 1, so we will complete the octet by putting a lone pair at this nitrogen. Now oxygen will check. Oxygen we have 1 2, so we required 1 and 2, so 4 and 4 8. In this case also we required 1 2. Here we required 3 lone pair, so then the octet will complete. Okay, so this is how we can draw the structure. And if you go for another structure, what will happen, you can take any of the lone pair, like in this case also you can shift this bond to this oxygen, or in this case this bond to this oxygen. Okay, so what will happen, this will give and this. Okay, so nitrogen and nitrogen, then oxygen, and then we have a single bond oxygen, then we have double bond oxygen. So only 2 lone pair, here we require 3, in this case 2, and in this case, so all the octet is complete, no? In this case this oxygen also can be changed. And quickly we look the formal charge. Okay, so let's draw the formal charge. Let's find out the formal charge. So formal charge in this nitrogen 1 2 3 4 5 0. This nitrogen 1 2 3 4, 1 is required here. Okay, so this will be plus 1. In this case 1 2 3 4 5 6 7, 1 is an excess. In this case 1 2 3 4 5 6 0. In this case 1 2 3 4 5 6, so 0. So plus 1 and minus 1 will be neutralize this molecule. 1 2 3 4 5, so this will be again 0. 1 2 3 4 5 6, this will again 0. 1 2 3 4 5 6, this is again 0. 1 2 3 4, this required 1, so this will be plus 1. Here 1 is in excess, so this is minus 1. This will neutralize. Okay, and if you calculate the bond pair and lone pair, this will also give you the same pitch. Bond pair in this case 1 2 3 4 5 6, so total bond pair is 12. electron. Lone pair 4, then 2 is 6, then 6 12, and then 4 18. So 4 6 10 12 16, so total will be 18. Similarly, in this case, bond pair is 1 2 3 4 5 6 12, and lone pair is 6 4 10 and 16. So as you can see that bond pair lone pair counting is equal in both cases. So this is how the N2O3 structure is drawn. Then we'll go for the fourth one, and this is the N2O4 nitrogen tetroxide. Again we'll draw the structure quickly. So total valence electron in this case will be 5 into 2 plus 6 into 4. So this will give you 34 electron. Okay, so the 34 electron, let's count the 34, draw the structure. So here we have again 2 nitrogens, so 1 nitrogen, then another nitrogen, then we have 4 oxygens. So 4 oxygen we can put 1 2 3 and 4, and we can put 2 double bond also, so 1 double bond here and 1 double bond here. Now let's complete the octet. So here we required 1 2 3 4, here we required 1 2 3 4 5 6, here we required 1 2 3 4, here we required 6. This octet is complete, this octet is complete. So bond pair 1 2 3 4 5 6 7, 14 electron bond pair, and in lone pair 6 6 12 16 and 20, so total will be 34. So structure is correct. Now we'll go for the resonating structure. So any of the, like we can go for this also, so this or this also, any kind you can go for anyone. Like in this case if we go for this, so this will happen like this. So the structure nitrogen with nitrogen, now this. Okay, then count the bond pair and lone pair. So bond pair 4 6 and 7, again it will be 14. Lone pair, so lone pair is 6 6 12 14 and 18 20, 6 and 6 12, then 16 and then 20. So bond pair is also 20. So there is no change on the bond pair and lone pair counting. Now the formal charge, so formal charge here in this oxygen will be 0. This oxygen 1 2 3 4 5 6 0, no it's not 0, 1 2 3 4 5 6 7, so we have one axis, so it will be minus 1. In this case again it is minus 1. Okay, it will be 0 in this case and 0 in this case. So what about this nitrogen? 1 2 3 4, it's required 1, so plus 1 1 2 3 4 plus 1, so this plus 1 plus 1, that is plus 2, this minus 1 this one, that is minus 2, so overall it will be 0, so it is neutral now. Similarly in this case 1 2 3 4 5 6, it is 0, it is minus 1, it is minus 1, it is 0, this is plus 1 and this is plus 1, so it is overall 0. So this is how N2O4 structure will be drawn. And now the last one, because the video is becoming longer, So quickly we'll take the last one, that is the N2O5. So nitrogen pentoxide, in this case we have a total valence electron is 5 into 2 plus 6 into 5, that is 40 electron total. Okay, let's draw the structure. So we have 5 oxygen and 2 nitrogen, so one nitrogen is combined with the another nitrogen. Okay, then we have one oxygen, one oxygen, one oxygen and one oxygen. Then we'll complete the octet. So first we can take the bonding electron, so this can be a complete 1 2 3 4. This can also complete, this oxygen is also complete. Then uh, we will put the lone pair. Okay, so 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 6. No lone pair because 1 2 3 4, the octet is complete, this octet is complete. So let's count the bone pair. Bone pair 1 2 3 4 5 6 7 8, that is 16. Lone pair 6 6 6 24, so this will give 14 electron. Then you draw a Renoni structure of this you need to draw. Okay, so this is how the total 5 oxides of nitrogen, and the structure of these oxides, the lone pair, sorry, the formal charge also you need to calculate here, how what is the formal charge and how the it is neutral molecule. Okay, so this is the task for you, complete it, and this is the structure of oxides of nitrogen. Thank you.